Hi all, let's just solve this question. This is related to calculus. They are asking which of the following is or are true. So there is a differentiable function fx with the property that f1 equal to minus 2 and f5 equal to something, then f dash x is less than 3 for every real number x. That's what it is given. I mean, that's what is being asked. So what we can do, we can just copy this particular statement. Okay, so these are the ABCD. We can just copy this statement on the next page where I have this theorem, which is mean value theorem, right? Because I will be using this mean value theorem, so it is better to copy both of them on the same page. Okay, so now let's just try solving this particular question. So what we can do, we can just have this only option A, and the remaining options we can solve little later. So I can just copy this particular statement of the theorem. Now what this statement A is saying, that f1 and f5 are giving something. So let's just find out some f dash c based on this theorem, which is saying there exists a c such that fb, which is f5 minus f1 divided by 5 minus 1, which means this is saying 14 minus 2, which is plus 2, divided by 4, it is 4. So they are saying there exists a c such that f dash c is 4. I mean, that's what this theorem says, but the statement says that for all x you have less than 3. But no, there is a c which is exactly equal to 4, right? So it means this statement is false. Why? Because there is a c that is giving me 4. F dash c is 4. And this statement is saying for all x this is less than 3. So that's why this is false. Okay. Now let's just go to the option number B. Let's just see if we can solve this. Now what they are saying? They are saying there exists a function. Yeah, let me just copy it. So there exists a function f such that f1 and f3 are giving something, and then they are saying that f dash x is greater than 1 for all x. Let's just see this. Okay, so according to the theorem, if I just paste the theorem here, so it is saying that f dash c is equal to fb minus fa divided by b minus a, which means 0 minus 2, which is plus 2, divided by 2, which is 1. So there is a c which is saying f dash c is exactly equal to 1. Is this true that for all x you are having greater than 1? I don't think so, right? So that's why this statement is also false. Okay. Now let's just see the statement number C. So I think A and B are false. So let's just see the statement number C, which is saying for all functions A is less than B. So if you just talk about this C, they are saying if A is less than B and F is less than 0 and FB is greater than 0, which means they are saying that if FA, see this is, let's suppose A, this is, let's suppose B, if you are here and if you are here, which means F is less than 0, FB is greater than 0, then you must be intersecting at one point, which means FC equal to 0. Is this always true for all function, or this is just true for the continuous function? See, it is not even necessary. I mean, you don't need to even define it something like this. So let's suppose this is fa is here, which is negative, but if from A onwards, okay, from A onwards, this is just positive, right? I mean, it is not even intersecting anywhere. So something like this. I mean, this if this is a discontinuous function, then this is not true. If this is a continuous function, yeah, then based on the Rolle's theorem, this is true. But currently, if you are asking for all functions, then I will say it is false, because see, this function is not even cutting at any point. Now let's just see this question. If f is differentiable, then it is continuous at x. I think this is true, right? So A, B, C are false, and only statement D is true. So I can just say this is false, this is false, this is false, this is true. They are asking about the true, so that's why D is the only correct answer here. So that's how you can solve this question using the mean value theorems. I hope you really like this question. So yeah, let me see the solution. This is false, 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 and then this is true. Okay. Now at Go classes, we are offering free engineering mathematics and free discrete mathematics. So if you have any issue in this particular question, you can definitely check out our engineering mathematics course. There we have clearly explained this mean value theorem, and you can definitely solve this question using the mean value theorem. Okay. Thank you so much.